Hello, this is the part 2 of the differential amplifier problem. Okay, now let's solve a few problems. In the previous video, I have discussed that how to use symmetry to solve this kind of problem. In this problem, we apply that knowledge to solve these problems. Okay, so you know these M3, M4, M5, M6 transistor identical, and this point P acts as a AC ground. Okay, so and this point acts as the or this axis is acts as a symmetric axis. So we can divide the circuit in the two part. Okay, and the M3 represent diode connected device whose impedance is 1 by GM3, and this M5 is behave like a current source. Now you may ask why it is a current source, because its VSG is constant, so it's delivering a constant current, so that's why it is a current source. And its output impedance is R05. Okay, so I can redraw the circuit, and it will look something like this. In the AC analysis, this point is a AC ground, and these two resistance are in parallel. So R05 in parallel with 1 by GM3, and this is also ground. This is our input, and this is the output. Okay, so what is the voltage gain here? As you all know, this is a common source amplifier whose gain is nothing but Gm times Rd or minus Gm times Rd. So V out by V in is the value of the differential gain is minus Gm1 R05 into R05 parallel 1 by Gm3. Okay, so this is the value of the differential gain. Now let's look the next problem. Now here the load is a cross-coupled PMOS load. We have to first find the impedance offered by this structure, then our problem will be easy, right? So from point X and Y, we found the output impedance looking from here. Okay, so let's draw the circuit. First, draw the AC equivalent of this circuit. Okay, so I'm trying to draw the AC equivalent of this circuit, and here we will place Vx and Ix to calculate the output impedance. Okay, so this is the Vx, and the current flow from the voltage source is Ix. Now if we able to find Vx by Ix, then we can find the impedance provided by this structure. Okay, now let us consider this node voltage is V1, and this node voltage is V2, and this is M3, and this is M4. Okay, now you can write um, V1 minus V2 is equal to Vx. Now if you consider this transistor M3, okay, so it's what is the value of VSG? VSG nothing but VSG3 is nothing but 0 minus V2, so 1 minus V2. Okay, so GM3 times VSG3 current flowing in this direction, but here VSG is negative, so actually the current flowing in this direction, which is nothing but GM3 into V2. Now if you look at M2, sorry, M4, then VSG4 is equal to 0 minus V1 minus V1. So similarly, here also current flowing in this direction whose value is GM4 into GM4 into V1. So you can write like Ix equal to GM3 V2. So V2 is equal to Ix by GM3, and here you can write like Ix flowing in this direction. Okay, so Ix equal to minus GM4 into V1. So V1 minus GM4, sorry, Ix by GM4. Now, from this equation, you can replace the value of V1 and V2 minus Ix by GM4 minus Ix by GM3 is equal to Vx. So Vx by Ix equal to minus 2 times Gm. If we consider Gm3 is equal to Gm4, if we consider Gm3 is equal to Gm4, M3 and M4 are identical. So you can see the impedance offered by this structure, cross coupled structure, is minus 2 by Gm uh, Gm. So as we can represent this structure as a two series resistance connected as minus 1 by Gm and minus 1 by Gm. Okay, so you can draw an axis of symmetry then, and the final one-sided circuit will be like this: M1 1 by Gm, rather minus 1 by Gm. This is AC ground, and this is V in, and this is my V out. Okay, so V out by V in is minus Gm1 into 1 by Gm. So this is our final answer, minus Gm1 by Gm. Sorry, I made a mistake. Here the resistance is negative, so answer will be positive. So you can see um, this circuit provide negative resistance, and which is useful for the application like when you make an oscillator and other kind of things. And this is the another problem. So this is now become quite easy. So this structure you can represent as minus 2 by Gm instead of this. And here, what is the impedance of the differential device? 1 by Gm5, and this is 1 by Gm6. Now just draw the axis of symmetry and easily solve the problem. I am not drawing the circuit. I think you can easily solve it. So here the differential gain will be minus Gm1 into 1 by Gm5 in parallel with minus 1 by Gm. So Gm1 to 1 by Gm5 parallel 1 by Gm. So this is the final answer. And again, this is another problem. So you need to divide the structure in this way, and let's draw the equivalent circuit with this problem. Look interesting. Actually, all this problem a very good problem which I have taken from the book of Desert Razavi. So you can follow that book. This problem are taken from the exercise of that book. Okay. Now let's try to solve the problem. Here the out is present, and here let's solve this problem intuitively. Okay. Now This is the diode connected structure here. This is the current source present, and this is my input transistor. This is Vin, and if you divide, if you make this by connecting two R1 by 2 in series, and the structure will be look like this. This is M3, this is M5, this is ground, and this is P out. In the AC equivalent circuit, this point will be also ground. So our task is to find V out by V in. So you can write this in this way: V out by Vx into V in by Vx. Okay, V out by Vx. Now V in by Vx. So first find this term. Okay. So you can see this is the Vx. If you look in this side, what is the impedance here? This is nothing but 1 by GM3. And downward, what is the impedance? R1 by 2 in parallel RO1. So this acts as a common source structure whose gain will be Vn by Vx minus Gm1 into 1 by Gm3 parallel R1 by 2 parallel RO1. So effectively its value will be Gm1 by Gm3. Now let's find out V out by Vx. What is value? This transistor M3 it acts as a common gate amplifier. Okay, so what will be the gain here? This is nothing but Gm RD. So Gm3 into what is the resistance here 1 by Gm5, and this, if you look downward, this provide very high resistance. So high resistance parallel with the low resistance is equivalent to the low resistance. So this value will be Gm3 by Gm1, sorry, Gm5. So the overall gain will be V out by V in, just multiply Gm1 by Gm3 into Gm3 by Gm5. So our gain becomes minus Gm1 by Gm5. So this and here is another problem. I think you can easily solve it. So this will be our AC ground, and this is a common source structure with a regeneration. So the gain will be minus RD 1 by Gm plus RS1. So you may wonder how I directly write this gain. Actually, before going to the this topic, you must calculate the gain of the basic common source, common drain, or common gate amplifier with different kind of configuration. So in this circuit, you can easily apply this. Okay. So this all from that's all from this video, and thank you for watching. If you have any doubt or any query, so please let me know in the comment. So thank you.